p40, I made a couple of graphs to go along with the examples. Right, so a region in the first quadrant enclosed by the graphs is a familiar problem. The region is rotated around the y-axis with the volume of the solid. Let's do it this time using the cylindrical shell method. All right, so what we would need again is a rectangle. If I can draw a rectangle. That rectangle is going to have a distance of p from its axis of revolution. And the height of a rectangle is represented by h. This one's going to have a dx as its thickness. All right, so p, the distance from the axis of revolution to the center of the rectangle. The axis of revolution is the y-axis. Distance from the y-axis to a point in space, the horizontal distance, is known as x. All right, the height of that rectangle well, not quite where I wanted to put it, but that'll work. That height is the distance from the x-axis, the vertical distance from the x-axis to a point in space, also known as y. All right, so p is equal to x, h is equal to y, so we're looking for a 2 pi over the interval of 0 to 1, all right, and that's because we're looking at a dx, so the region begins and ends at 0 and 1 respectively. P is x, h is y, but y in this context is the y associated with the curve, which is e to the 2x. So e to the 2x dx. So integrate that, and we'll have our solution. All right, so, I mean, you could use substitution if you want, but you could also type it into the calculator. So going from 0 to 1, we got the x, we got the e to the x, and we got a dx. All right, 6.2831, that looks an awful lot like a 2 pi. All right, so coincidence? I don't know. All right, so it's in the neighborhood. Ah, well, coincidence? Oh, no, mistake. 2x. There we go. About 13.177 units cubed. All right. So one quick integral gets the job done as opposed to using the washer method. Same idea for number 4. We're rotating it around the y-axis. So our arbitrary rectangle is actually going to have the same ingredients. It keeps disappearing on me. It's going to have the same ingredients as the previous case. We're going to have an x, and we're going to have a y here. So it's 2 pi over the interval of 0 to 7. The p, distance from the axis of revolution to the center of the rectangle, is x. H, the height of the rectangle, is the distance from the vertical distance from the x-axis to a point in space, which would be y. And the thickness is dx. All right, with y being the only thing that we would have to substitute in. So over the interval of 0 to 7, we have x, and then we have the y being replaced with x plus 1 to the 1/3, and then we have our dx. Goes right to the calculator. Two pi multiplied by the integral over the interval of 0 to 7, x, and it's the cube root, so I'm going to use the 1/3 power is cube root, so math option 4, x plus 1 dx. And so we're looking at what we had before when we did this problem with the wash method, 271.299. And that's again units cubed.